Oradayım şu anda. Good morning. This morning we have Christine and Dan Jingji. And we're actually expecting to see some more attendance. I say let's wait for 5 more minutes. And yeah, I've arrived. So let's wait for 5 more minutes. And we sent out the link to our Discord channel too. And then we'll see how it goes. See you in 5 minutes.
Hi, everyone.
Good morning. It's the morning here.
Good morning.
What time zone you're at? Is it the end of the day or midnight? Or same as here?
It's 9 a.m. here in Barcelona.
Three p.m. in China.
I didn't understand. So, what time is it?
3 o'clock
3 o'clock
afternoon.
afternoon.
Yeah.
Okay, that's
Yeah.
nice.
I missed Yarvan. Have you said anything, Yarvan?
Yes, it's 9 a.m. here in Barcelona.
10 a.m. Okay, good. And any night timers? Okay, they're sleeping already. Okay, so yesterday we started, and some of you were active. We know the struggle, but haven't heard from some of you. And through Discord, we had some messages coming and going, and today we're going to be working on in the couple of the earlier hours, we're going to be working on the data set collection and preparation phase and task related problems and solutions. If you have problems in this preparation process, and reviewing the collected data sets and discussion. So afterwards, we shall be talking about the CNN and Pix2Pix CGAN on Google Colab. We already started talking about it, and you've seen the our Colab notebook. So Mustafa will be going through that step by step. And if you have, if you're having problems about the data preparation, again, Mustafa and Selen will be helping you out. And let's see where you're at. Please let us know how it's going. If you're having any problems, any struggles, anything you didn't understand from yesterday's sessions, please let us know.
Yes, I have some problems, issues. And the one is I solved the problem, the first problem. And the second is when we run the workshop 2022, the IPMB, the file, the step, when the step training the model, I can train it, but can how many times it will running?
It
How long?
depends on the epoch
Yeah.
times, and you need to connect to the GPU for that training. But
Yeah.
we will cover the things and all the issues today, actually. Yesterday, we only covered the data preparation part and the converting the downloaded MP3 and MP4 files into WAV formats and generated audio spectrographs. I assume your problem is related to today's task while training the model. So we
Yeah.
might give answers to you after this session, during this session, actually today. But did you have already collected your data set?
I have already given my data, personal data set instead of yours.
Okay, it's fine.
Maybe let me share my
Okay.
my screen. Let me see. So, is that okay now?
I can see your notebook. Colab notebook.
Yeah, cool. In this step, I'm running it now. It's
Yeah.
already about 130 minutes. But if I stop it, right, and run it again, it's totally run from 0%, right? It
No,
needs
no,
to do it again.
Can you go down again slowly?
Yeah.
No, at the training part, like 8,000, that part. Can you go up? Let's see. You have saved plot and model, and it's like how many data you have?
The data, let me see. It's based on this one. Transit out alternative.
No, this is where it saves the model.
Let me see this is my data, and
The paired one, the double data.
double data. I mean this one.
You have to pair them somewhere.
Let me see. Alternative. The size. Sizing.
The train. Maybe the train folder.
The train folder. Yes.
Yeah. Okay.
Yeah. I think it's 120. 120. Let me check if this. Yeah, it's 120.
It's a little bit small data, but it can work. I mean, but it will work like an hour or maybe 2 hours.
Okay.
It will train. It will train. You
So-
can see that you can if
Yeah.
you go to this train results alternative folder in your drive.
Yeah.
mm,
Yes, this one.
Yeah.
This is
No,
from
no,
yours.
not this one. Not this one.
Okay.
Train
Let me
results
send
alternative. Yeah. Okay.
Yeah, this one.
You see, this is your first epoch result.
Okay.
It has like 10. It will give you 10 results like that, and
Mhm.
final one will be the final result and the final model. I will
Okay.
show how to work with that today.
Okay, I understand.
Right.
And so can I modify something like I can when I stop it, I can resume it from maybe the previous let me see the previous this model and this MPZ file. Can I resume it? Just not shut it down and go it again and calculate from 0% again.
Yeah, it will always start from the scratch.
Okay, I know. Yeah. So I think I finished this. And yesterday I made a question on Discord. It's the problem about the transfer the MP4 files to the WAV. This
Okay.
yeah.
Yeah, I just updated the original notebook from our drive, and
Yeah.
it was working, but I don't know what's wrong with Colab. It just stops working. So I just updated the MP4 conversion part, and it
Yeah.
works right now.
It's not working on this part. It's not working in this part, but it's working in this part. Covering all MP4 files to
You have
mono.
MP4s, right?
Yeah. The
So-
YouTube
so
download
it-
file.
Yeah. If you have MP4s, you will run this part.
Okay, this
Not
part is
not
okay.
not the MP3
Yeah.
MP3 part.
Okay, I see. And I also searched for some like MP4 to MP3 like Colab.
You don't have to do that.
Yeah. Yeah, I tried this, but I finally I find this part and try it, and
Yeah.
it just done. Yeah, no worries. But this part it has worries.
Yeah,
I don't know. Yeah,
I don't know what happened, but it was working for MP4 and MP3 files. But
yeah.
yesterday I tried it, and yeah, it gave the same error to me. So this
Mhm.
part, the error part, the error the gave you error part. It's like for MP3s now, and
Mhm.
the below part is the MP4s.
Mhm. Okay.
So you
So
don't have to
just
run. You don't have to run the MP3 files part.
yeah, just to recognize which is if it is a MP4 and if it is a MP3. Yeah, just and
Yeah,
put it in the right part, right?
yeah.
Okay. Okay, cool. So I found that. So about 120 images, maybe it should be using 3 hours to calculate to
You are
generate
running.
the
You are running on GPU, right?
yeah. I buy a 1 month
Oh,
pro.
okay, okay.
Yeah. So
So it will be done in like 1.5 hour.
okay. So I see. So I think this is no problem
This is
at the
afterwards.
last
Yeah,
yeah.
yeah,
It would would be fine. It would
yeah.
be fine. Yeah. Okay. Thank you.
Okay.
So maybe it's better to say to update the Colab notebooks than if the conversion doesn't work with you guys. So Mustafa had already uploaded the notebook in IPNB file in the Google Drive. You might want to download it and upload it again in order to convert your files without any errors. So who else had a problem yesterday about data collecting the data set, transforming the files?
Yeah, I didn't get the chance to work on it yet, honestly. So
Maybe you
nothing
can
yet.
try that, the result code for converting the MP4 to WAV. The other participants, what about you guys?
Yeah, I find a better way for scrap the image from website. Yeah, maybe
Using
this is. I find another way we can
another
download
way, okay.
images. Yeah, not from the
There are
the-
millions of ways. There, every time somebody just publish something that we cannot can follow the face of it, but it
yeah.
would be better to just check the many more resources as we can have time.
Okay.
Okay. So
Um,
if you would like to share with us the method that you just followed, we will be welcome. It might be beneficial for our participants too, but no pressure. So the others, Khan,
Uh,
Christine, Jumboli, Chen, did you have any problems during the data preparation, or how many data that you have collected yesterday? Should I ask that?
May I have one more question?
Okay.
And yeah, can it generate? I saw the final image generate. It's about 25.6 pixels. So can I change it to 513 pixels or 512
Yeah, you can change it.
by the MPZ file?
No, not. You can change all the training set to 512, or just the last generated part.
Okay.
It's up to you,
Mhm.
but you can change it.
Okay. Okay.
Okay, so if you're not having problems in the data preparation phase, that means you have a data set that you can run the model on. And Mustafa will be guiding you through the Colab page within the model through the algorithms. Yes, Mustafa.
Yeah, okay. I will just continue on Colab. I'll just share my screen. Everybody can see it, right? Okay.
Yes.
Okay. I'll just continue from there. Yesterday there was a error in MP4 conversion, so we worked on that and we solved that. There's an update on the code. You can download and run it through here. So when you these are the file locations of yours. So this file location is adjusted according to our drive folder, but you can adjust it according to yours. So these are just file locations, and if these are mistaken, so it will give you like there's no folder or file in this location error. Just be careful with that. And we just convert the MP3 and MP4 files to mono WAV files, and then we split them here, like in 6 parts, 5 parts, 7 parts, whatever you want. After that, we turned them to spectrograms. This is for all folder. Turning all files in a folder to spectrograms, and this is again your location where you want to save the spectrogram files. You can adjust it according to your drive folder, and then this is for just single conversion to show you that this was this spectrogram files conversion. So you can choose any of them to work with. This part will change all the splitted WAV, mono WAV files to this amplitude spectrogram image. Okay, so before training the set, we have to again resize the images and pair them together. So this resizing images part will do that for you. This path is your spectrograms or the architecture files. Actually, it has a 2-part. They are doing the same thing. This is the resized spectrogram files, and direction path again where you want to save the resized spectrogram files, and then just in a for loop it just resized all the images, just resize 600 to 600. You can change it to like 512 to 512, 1024 to 1024, whatever you want, and it will just resize all of them. But for pix to train, it has to be just a square image. Just this is the important part. And when you done that, you will see like spectrograms. I will show you spectrograms. Okay. Now, this is the spectrograms before resizing them. It is originally square, but the size of it is too large, and when we resize them, it just gets smaller and square. again, here we are doing the same thing for just architecture images, and it will give us. Before that, unprocessed image. Yeah, before that, like we have this type of image, like, and when we resize them, it will turn to just square. So okay, these are just resizing the images, and then this is the pairing part. It's just make two images as one single file to train the pix-to-pix algorithm. So it again, source one is your architecture images. Source two is your spectrogram images, the file locations of them. You can adjust them. You will adjust them according to your drive folders. And the destination part is where you want to save the paired images. Okay, so again, this will be adjusted according to your drive folder, and then it just opens, and for all the files in these folders, it just runs a for loop, which is like running in a loop, and it just pairs the images together and make them a single image, and it will just be, the result will be just like that. Yeah. Left one is the spectrogram and right one is architecture. Left one is your input, right one is your target file. After that, this is the part where we run the machine learning algorithm, pix-to-pix algorithm. These are the libraries for required to run it. You just run it, and then here this is where we load the images. This is the pair image location, so you can adjust it according to your drive. In our case, we just run with this one, alternative ones. You can pair them. You can adjust them according to your drive folders, and this is where you want to save the zip file. So pix-to-pix is reading all the images at once and make them a zip file, and then run through that. So this is where you want to save the zip file. Again, here we have this file. When you copy the path from there, you will see that these are the same. You see. You can just copy the paths from here to easily adjust the code. Okay. So when we run this, it will just create this. I'll show you the zip file here, this one. We just work with, we tried lots of them. It will just create the zip file. And then this is the where you confirm, just confirming the images to see that you have loaded correctly. So when we run this, it will just give you this. There's 226 images. They are all 256 to 256. And this is the input, this is the target file. Yeah, so we load it correctly. So this part is for developing discriminator model and generator model. So pix-to-pix is there's a GAN algorithm, and it has actually two algorithms: the discriminator model and generator model. Generator model just creates a new image, and discriminator tries to identify if it's a fake or real. So it is training itself actually. it's kind of cool. So this part is for the defining the model and developing them. So we have to run these libraries too. So defining discriminator models, yeah. There's some convolutional layers of the discriminator, and you can work with like this. This is for 256 to 256 pixels, but if you like to try the code in 512 to 512, you can just open this part, another layer, adding another layer, and you have to adjust just this one to like that. We will work with Pix2Pix is working with 256 to 256 perfectly, and that. So I'll just comment them out, but you can try that. If you just want to work with 512 to 512, you have to change here, and I will just add comments afterwards. You have to change here, like when you paired your images, when you loading them, you have to load them as 512 to 1024, and this part. So now it's not your first 256 pixels is your input. Now it's your first 512 pixels is your input, and the rest is your output. But we will go there. I will just add comments what you have to do afterwards. Okay. So yeah, these are discriminator model. And then we defined the generator model. It has 2 layers, and every layer, like it has 2 models, and every model has 7 layers. Okay, so again, when you have to try to run the double size images, you just have to double it from here. ReLU activation. These are just the machine learning features, machine learning parameters where it tries to run, like activation function, dropout function, batch normalization. These are just parameters, and these are generally same for all the Pix2Pix models. You don't have to work with those.
I have a question here.
Yeah.
Why are the different layers in different sizes? Like you have 512 and then 56 and 128.
Oh yeah, okay. So you work in the images. So actually you have we have 56 to 256 pixels, and when we're working on them, when we create the images, it works on like small to large folder, and in encoding in generating the image, it works from small parts to big parts and generates an image. And the decoder part is just like going from whole to the small parts to decode the images. So it's according to our pixel sizes, and it's like going from small to large and large from the small to just confirm its generation and training.
Okay, so if we were doing 1024 by 1024, then our largest number should be 1024 in here.
If you are working 1024 to 1024, so our largest file will be 2048.
Oh, so it's
And
double.
we have lots more layer here. So
I see.
we will start from 64 again, 128, 256, 512, 124. It will become right here like 2048, 2048, 2048, and it will have one more layer too, like D7, D8, and D9 will come again here in here. E9 will come, and the last 2 or 3 ones will become 2048.
Got it.
I will just add them. I will just comment them to here.
And one more question.
Yeah.
In the previous part, like, what's the logic of pairing the spectrograms with the architectural images?
Pairing. This
Yeah.
part, right?
I believe so. Yeah, like pairing this. I think the one before that, where you have a half an image that's a spectrogram and the other half.
This one, right? This
Yeah,
one.
yeah.
This is
What's
spectrogram,
like,
this is architecture. Like
Yeah.
this is for just easing the this is just lowering the files for pix-to-pix algorithm to read. Like the first square one, the first 256 to 256 pixel is your input file. Actually, you are trying to convert this spectrogram to architectural image, right? So the first square is your input and the second square is your output. And this is just pairing them is just like this image belongs to this image belongs to this image. It just easing the job of the algorithm and just lowering the number of files read by algorithm.
okay.
It's actually inside it separate the images and run through them. Okay, so we defined the generator model.
So,
In here,
sorry, Yarvan, your question, the logic of it, is that technical in terms of the model or as a reference to the whole logic of why are we using spectrograms?
No. It's more technical of like why that specific spectrogram is being paired with that specific image. Like, what is the logic there?
okay. So in our part, it's actually random. Like
It's random. Okay.
we set it random. But if you are working more specific, like this spectrogram needs to belong to this image, you have to pair them according to. So in this part, we are just pairing them randomly because they all belong to a given part, and it doesn't matter for us which spectrogram belongs to which architectural image. So we just pair them randomly. But if you are trying to pair them one by one, because it is just matters. So you define the spectrogram and architectural images. I will just write a part for it after the workshop session. We can just adjust them accordingly.
Yeah.
But
so
in our part, there is no specific spectrogram, specific architectural image. We just pair them randomly.
Okay, I understood.
you
Thanks.
need a different kind of classification for that, to train the computer according to, for example, very specific local information or temporal information, like saying that the first 100 years, the second 100 years, according to dates. So that's the future steps. It's among the future steps of our research. But right now we have all the a batch of information for music and another batch for images. So that's where we started. But going further, we're going to be refining that data and train it more specifically.
Yeah, that makes sense. I have another question actually. Is it So here we're pairing, let's say, spectrograms with architectural images. Is it possible to like pair even more data together to, I guess, have more inputs to generate like different outputs? Like, can you pair more than 2 different inputs together?
Like spectrograms and another
Like,
type of
let's say
imaging.
spectrogram, architectural images, and let's say, I don't know, like painting images. Like, let's say you're trying to gather all the information that happened in that 100 years in that specific region, from like culture to art to architecture to music, and you're pairing this stuff together. Is that possible to pair more than 2?
Yeah. You can
Okay.
try. The results will be very different. I
Right,
think,
right.
but it can be done. Yeah.
Okay. Cool. All right. Thanks.
So okay, I'll just continue. Here we just put them together, the generate and discriminator model together, and here we are just loading and preparing the training images. Like when the red images read from this zip file, we are scaling it from 0 to 255 pixels. So if you are working with like 512 to 512 images, you have to scale them 0 to 511, so that it will just become the double it. You have to work with the 255 and a half to 259 and a half. So it will be adjusted here, but I will just write them again. But 0 to 255 is like 256 pixels actually. So this is why the programming is like working from starts from not 1, it starts from 0 always. So you have to consider that here. So we just prepared training images, and we just read the class labels. We just defined the real class labels and fake class labels, so that the discriminator will tell the difference between those, and it will say the generated image is fake or real, and give feedback to the generating model, and generating model will update its features accordingly to generate more real images, or like generating the same images. Here we are just image quality, choose a final model. So we are defining the features of it. These are just the technical part, and these are all same for all the pix-to-pix algorithms, and it will just create real image A, real image B, and fake image B to tell apart tell the difference between fake and reals, and then it's after defined epoch numbers, it just save the model, and then there's a plot of the generated images. So this is again your this part actually. This part is your file location, and it will be adjusted according to your drive folders. You will just adjust them. This is where you want to save the training results. So a model and plot. It will be. I will show after this part, and this is where we again read the zip file from our drive folder. This is the training images actually. So when we just run them, it will start, and we have 226 images. So we have like 220,600 iterations, and it's just like 100 epochs. And after 1,000 iterations, at every 10 epochs, once at 10 epochs, it will just save and plot and model for you. It will be just right here and like training results. Okay, so we just saved the final model, but the plots will, you can see after first, this is just the first model, and it will become better and better in each iteration. As you can see, it becomes building in the images. And the last one is here. Okay. So as you can see, it can generate the whole building now from just spectrogram files. Okay, so this part is your training. It will take like 1.5 or 2 hours or maybe 3 hours. It can change. It is changing according to the GPU provided from Colab. So Colab is not always providing the same GPU to you, so it can change according to its features. After done the training part, we will translate the images, so to see if we generated correctly, if we can generate it correctly. So this is for again just libraries needs to translate the images. This is again just like in the training the model, we just discriminate the images from each other, input and target images. This is plotting part. It will create our plots according to like the source generated expected. So these are the labels we want, and we open an plot figure. We divide them into 3 parts with subplot, and we just gave them titles in here. And we just load the dataset again. This is your MPZ file in your drive. You will adjust it. And this is the result of the model. Like this is where you want to save the model. So in this folder, now there's a model file, just like that one. Actually, you will have 10 of them. The last one is the final model. So we will work with that. But if you want, you can work with earlier models too. When we run this, okay, I will just run those again. It just take a random sample from your training folder and generate a architectural building from this spectrogram file and just compare them with the real image. So this is the actual checking if your algorithm is working correctly, if your model is working correctly part. And yeah, source file, expected file, and generated file. It's quite same thing. So model is working correctly actually, but after that we have to translate new spectrogram files. So there is the spectrogram files that has not been read from the has not been trained over, and we just want to see the model generate new architectural images, so that we are providing new spectrogram files to see what it will generate. So this is just loading image function, 256 256 again pixels, and then this is your spectrogram file location. So new spectrogram file location from now. This is what This is what you want to try. So that like, and this is the again model location. After the training, it will be here again, this folder. So if we run this, we can see that it will just run and generate an image for us. Okay, yeah, it will generate some image. You can see some outlines of, I don't know, building maybe. But it is still a little bit abstract, I think. So the data size is matters in this part. So we have 226 data, but to machine learning algorithms to work correctly, we need like over 500 data at least to work it more precisely. But when you give the like, let's try some images. From let's see.
So is this the final image that it's generating?
Mm. I think Mustafa is having just a second. Yeah. So we were actually about to give a break. Let's do that while Mustafa can reconnect, because I had a similar problem. I don't know why we're not at the same place, but so please try and work on the Colab right now. Or if you want to give a break, let's meet at 11:10. Okay.
Okay.
You mean in 10 minutes?
Yes.
Okay, for me that's like 1 hour, 10 minutes. I'm like, oh,
Oh, sorry. Yeah.
Yeah.
1 minute. Sorry.
10 minutes makes sense.
Okay.
Okay, cool.
Yeah. See you.
I'm just sorry, there's a bad connection. Sorry.
Mustafa, we
Yeah.
were, I was going to remind you that we need a break.
Oh,
So
okay.
I told friends that we're gonna give a 10-minute break.
Okay. Cool.
I'm writing it down.
We can continue if you like, if everybody's here. Can everybody see my screen?
Mustafa, sorry, I couldn't hear you. Well,
No, I didn't say anything. I just asked if everybody's here and everybody can see my screen, but nobody's answering. So
Yeah, I am here actually, and I have a question.
yeah,
Uh,
okay.
When you say, like, previously we're talking about real image and fake image, in this case, like, what does fake image like exactly mean?
No, so like this is the fake image, right?
Okay.
Actually, and again, it's in here we can see that true. This expected part is the real image, and generated part is the fake image actually. And when discriminator cannot tell the difference between those two, the model is it means model is working successfully.
Okay. Okay. And is the expected image, is that like a real picture that exists?
Yeah, expected image is from our data set.
Okay.
It's the real image. It's the
It's
real.
And here it's basically generating images as close to the real image. And is that what's happening?
It learns from it just learns that the spectrogram files here, this spectrogram files, and the relation between this spectrogram and this real image, so that when you provide this spectrogram file, it after the training part, after 100 epochs and like 20,000 iterations, it just learns that every pixel in the input file, every pixel has some another pixel relation in the real image, so that it learns the relation, so that when you provide the input file again, it will generate this image. So it means that it learns that these pixels means these
exact
matching.
Okay. So in this case, you're just learning, it's not generating any new images. Like the generation of the new image is like all the way down at the end.
No, actually, this is a generation of new images, but it because it learns from these images, it can generate a very similar image to real. But when you provide a new, not read in the training set spectrogram file, it generates a whole new image. And because our data set is small, kind of small, the generation is not like you can tell maybe the again outlines of an building, but you cannot say exactly this is a building. So
So I see.
Oh.
So like here in the end, the last image is generated by giving it a new spectrogram file.
Yeah, yeah,
One new file.
yeah,
I see.
exactly, exactly.
Based on everything it learned before. Okay.
Yeah,
Got it.
I will just connect to drive and test it for like another
Mustafa,
images. Yeah.
we may share, let me share that image from our presentation. I'm going to share my screen.
Okay, I'll just stop it then.
No, you don't have to.
Oh, sorry. Okay.
I mean, I don't know. Are you seeing my screen right now?
No.
No? Then you need to.
Okay, I just stopped.
Okay. I thought we could do it simultaneously. Okay, so you may want to explain it from here to Yarma. Let me. So that's how it goes, Yarvan.
Oh yeah. Yeah, totally.
Yeah, you feed the audio, but spectrogram, and then it's encoded and generated. The discriminator tries to tell whether it's fake or real, and it keeps going back and forth within the algorithms, and finally, here you can see how it goes within the network, the neural network, and it keeps getting refined each time it goes through this process. So the generator learns to generate better images from the feedback that is coming from the discriminator, right? So the better the discriminator gets, the better the generator gets.
Got it. Yeah. And so to train this, you were saying that we need at least 500 images in the data set.
No, you can train it with like 5 images too, but
but you won't get results.
Yeah.
So, but let's say you have 500, or let's say you have 1,000.
Yeah.
You train it only once, and that's enough, or is there like
No, just in one training, there's like 100 epochs, and each epoch means that it runs all the data from 1 to 5,000 from again and again. Like it just run all over all the data 100 times in 100 epochs, and in epochs there's some iterations, and iterations are just like working with data again and again, so that like actually in one training you are training the data lots of times to the model.
Right. Kind of like how evolutionary solvers work in Grasshopper.
Yeah.
Got it. Okay.
So when the data increases and epoch time increases, the process will take so much more longer, but the results would be better and more precise with more data and more epoch values.
Okay, cool. Thank you, guys. Sorry, I'm a total beginner at this, but I'm trying to.
This is the quickest part of the machine learning, actually. You have to just how to implement the model correctly to know what parameters that you want to change in order to expect better results. So I think those are the most important parts of the machine learning. So don't hesitate to ask that question too.
Yeah. Cool. Thank you.
Maybe you can try with lower images, like 500, 200, etc. Maybe you can just increase the epoch size and number of epochs to maybe you can just see what it will give you as a result, or maybe you can just play with the number of batch size. These are just feature of training model. So if you increase the epoch number, it will take longer to train. And the base size is like the how many times in epoch it just runs the data. So if you just increase it, it can generate some different outputs. I think maybe we can play with them too, if you want. I will just show you that like I will here take another spectrogram file randomly, and okay, so sorry, I'll just do that.
Here, are you taking
Okay,
one of the same spectrograms that you used for the training, or these are different?
I don't know. I just took it randomly. It can be one of the data. It is not one of the data.
Okay.
But when you see one of the data, you can tell. Okay, so I'll just give another one. Again, but like you can see the outlines of the building. It is trying to generate a building, but maybe we can here try. I don't know this one. And yeah, okay. See, as you can see, this is the one of our training data set. So it generated antennas too.
And if this is like, if you use the spectrogram in the training set, is it trying to generate the image that it is paired with?
No, it is not trying to pair images, but it is trying to generate a new image. But because it learns from the spectrogram file we provided, it knows how exactly the matches of the pixels it has.
Right.
So it generates the exact match of the spectrogram file.
Mhm.
But if we try something different, so it doesn't know how exact the matches of the pixels, so that it tries to generate a new thing, like this one. If we increase the data set, like again, we have 200 and something images. If we increase it to 500 or 1,000 even, these new results will better and better. Actually, we were expecting you to share your training data set with us to combine them as one big data to train the model. But that's all. I think we can hear from you. We can hear from your problems and errors you get.
So yes, I think we need some more interaction. So Arife, are you there?
Actually, I have a question about the data sets.
Yes, Kaan?
Yes. Actually, I create the architectural data images and I converted successfully. There is no problem about that. But the matching parts we learned today, the music data, the MP4 and WAV data is after the conversation. The matching part is I'm just stuck with it. So maybe actually the one of the question is I have a 100 music data have. The count is the 100 approximately. But my images is the higher than the 100. So is to need to match the numbers, or the algorithm is matches the randomly and automatically? This is the one question about that.
Oh, okay. In this part, the pairing part, like
Yeah, parent part.
if you see, yeah.
Mhm.
Okay. I'll just come to that. Yeah, okay. So in this one, we have lower data in architectural data and higher number in spectrogram images. So we just gave the architectural images file number as an input here. So it just create the data as much as the lower data set. Like if you have 100 music file, spectrogram files, at the end you will have just 100 data. It will not use all the architectural images.
What is the picking? How can I say the select? So the program select the image data randomly, or
It just selects randomly. We just
Randomly.
created randomly, but if you want to select them specifically, you just have to
because we just some create different configurations, some part of this algorithm. I remember we just double-lize the numbers, some part of that. So I missed that part. What is the customization we can create on this code? What's our limits, or the randomness? How can I say randomness? Key numbers we can change it on this code. I just
okay.
yeah want
Okay.
to say that again.
Okay, so actually you can change almost every part of the code,
Mhm.
but sometimes it will give error, sometimes it will not give error, and sometimes it will give very successful results. But the parts you need to change obviously the file locations.
Mhm.
You just adjust them according to your drive folders. After that, you can just change the here, like yeah, you can change the image size you are providing algorithm. We just work with 256 to 256, but you can work with 512 to 512 or 1024 to 1024. You can just change them here. After changing here, you have to change them here too. So this is because this is loading the paired images. So first 256 pixels is your input, and rest 256 pixels is your target file. So if you just working with the bigger files like 512 to 512, it will change. So this time your paired image size will be 512 to 1024. So your first 512 pixel will become your input file. So this is just sizing parameters. You can work with all of this actually. If you want, if you don't like to work with 64 pixels as a smallest data set, you can work with these two. Like you can work with 32 too and get bigger, or you can just work with 128 to the greatest. You can adjust all of this, but it has to be just to be getting bigger and bigger, like doubling the sizes. Just if you work with if if you just start with 128, so this will become 256 and 512, 1024, like that.
Okay, thank you for the answer. Actually, I think the resizing of the image part is important. Of course, I believe if we double up, if we just put the number of the doubles continuously, creating some big resolution output image, if you want, we increase it. The processing part is increased, I believe. You mentioned about the 1 hour to 3 hour
Yeah.
CPU power based process on that part. But what's the optimal resolution we can get on the final image file? Because it's the lower resolutions, there is something image came from the algorithm, okay, but it's can't be clear to understand the pixels and this relations of the output. So what's the optimal resolution, call it a resolution, and the optimal time we can get the this image part? Any
So-
suggestion about that?
Yeah, the pix algorithm's optimal size is like actually 256 to 256, but it works fine with 512 to 512 too.
Mhm.
So, but this image here, okay, I will just go. Yeah, this is a 256 to 256 image, but after saving this, you can adjust, resize the image, and you can have a 1024 to 1024 too. But it will create an 256 to 256, or if you work with 512 to 512, it will create for 512 to 512. But the smaller these 256 and 512 is optimum size of images the Pix is working with successfully, and the training amount is like it just changes with the data. So if you have 100 data, it will get lower and lower. So in a half an hour, or maybe maximum an hour, it will take.
And after that, with the output of the algorithm, for example, this final image created with the new spectrum, and this image is just we can see. We can we actually use the different algorithm to increase the resolution? Yeah, super
Yeah.
resolution algorithms.
Yeah.
Like
You can work with them. Yeah, there are some algorithms that based on machine learning or not machine learning, but there is some quality increasing algorithms for images, and you can work with them too.
Okay, thank you.
Okay, so do we have other questions? I mean, even if you've fallen behind, please let us know where you're at. Do not struggle by yourselves. So for today, we introduced what we plan to do. Until 12, we're going to be here connected on Zoom. And please try running the codes and just experiment on that. And if you have questions, we're going to be around until 12. Thank you. Okay, so we didn't hear from you. Any questions, any struggles? Christine? We haven't heard from you. Dan Jingji? Jumboli? And Su Hua? I hope I'm pronouncing right. We haven't heard from you. Okay, so if you want to work on your own data and if you work on your data and the models, tomorrow we're going to be discussing the work and the outcome. And if tomorrow you have questions, again, we can talk about them. So, Khan, do you have any comments? I know you're working on the model, but do you have any questions, anything, comments? Before we close for today, and tomorrow we're going to be meeting again in the morning.
Actually, I'm just working on the process, and I use this algorithm is new to me, of course, and I just try to understand the spectrum principle, the AI generated algorithm, how to works with that. I'm just in background research on that part, and I just used the couple of times on this Colab file time to time to generate the different kind of results, and I changed the outputs of them, of course. So sometimes works, sometimes didn't work, of course. And this is the main principle.
Yeah, the main challenge of this
Yeah.
machine learning.
Yeah, machine learns, but we just understand how machine learns, and we learn from this mistakes from that part. And now actually I have some problem with the audio files. Yesterday this didn't happen to me, but now I think the Colab file is changed, or my is older version. I don't get it right now, but can I share my screen to solve this?
Sure.
I believe we have a time for that.
Yes, we have time. We just said we could close earlier, just if you don't have any questions, but if you do, we are here. We spared this time for all of you.
Thank you. Yeah, that part yesterday, that part is work for me, but I this morning I create this new the sound list from the alternative Orient. I just try to implement the as a new data. Yesterday I used the shared drive audio data, but it's for some new generated data I want to create. So I picked that. This is the alternative version of the Oriental music to Frank Gehry's architectural masterpieces I want to integrate with them. So I just download all of the data on that part, and And converting part, I'm stuck with that, and I want to show this problem.
Okay, I'm just. Can you show me the error too? A little bit down. Okay.
Yeah, this part.
No such file or directory. It just says that the file is not there. So maybe the. Oh, okay. You have to just add slashes at the end of the file locations. Like
Oh,
there's audio.
yeah.
Yeah, and the destination file too. Okay, it will work.
And this is the old version. Yeah. Oh, okay. Thank you.
Okay.
So,
This is converting single file.
single file. Because of this code is the single MP4
Mhm.
file.
Single
Uh,
MP3 and all MP3s. The
All
last
MP3s.
one is all MP4s.
Okay. Okay. I get it right now.
Not that one.
The one at the below.
Oh, okay. This is the MP3.
Not that one. Yeah.
Yeah,
Okay.
this one.
Yeah,
Okay, thank you.
it will work.
I just simply right click on that part and just press
Yeah, but it doesn't add the last slash.
slash.
Yeah.
This is the issue. Thank you for that.
Okay.
And actually, I want to show the main principle we working on that part with the audio files to Spectrum we created, and we pair that data set images to Spectrum, and this Spectrum, the machine learns from the Spectrum to what's the real image matching image, and after that part, the Spectrum is generated, and the new generated unique spectrums create some unique images on that part. This is a complicated explanation. I can't explain very well, maybe, but there is some process parts on that part. So I just try to understand what is the main topic of the what's the differences came from the audio files to image files. I just want to understand that part. Let me try to explain as a simple again. I just try to implicate the different kind of sound files on that part, but my image data architecture dataset is same. So any differences can be happen if I change the playlist of the audio files. If anything changes, of course the spectrums are changed, but the machine, how for example, I just implement the electro music data on that part, the images is like a crazy, or I just implement the classical musical, some slow tune musics I just implement. What's the output is you just can't be related on that part. I just want to understand this
Okay.
situation. Yeah.
The machine doesn't matter which data you gave it. It doesn't matter. It just finds the relations between the two data. So if you just gave electronic music, or if you just gave some punk rock, if you just gave some classical music, it doesn't matter if it's like a low tune spectrogram or very noisy spectrogram. It doesn't matter. It just finds the relations between two data, input and target image. It doesn't matter. So for the machine, it doesn't change anything. But for us, we say, oh, there's a relation between electronic music and architectural image, building image. Or we say, oh, there's a connection between classical music and building image. But the machine, it doesn't matter.
The novelty of the projected model is to, when you upload a new song to test to generate an image, and if we upload a total new song in the same file, for example, just think that you have changed your model using the rock music, and with the images that you have paired. And the machine learns how to convert this rock music to that kind of an image. And when you give the machine a new music data that doesn't belong to your initial list, which is actually any other rock music file too, it will generate by this learning process a new kind of an architectural feature from listening to that file by converting it to that spectrogram. So machine learns how to convert this specific kind of like the music type into a specific kind of an architecture. You can try to alternate it through training the model with various music types, gens, and various architectural images selected from different regions to see how it works with like this folk music or the rock music or slow music. But it depends the machine learning algorithm in terms of understanding the relation between music and the architectural data. So it doesn't matter, as Mustafa says, whether you give rock music or pop music to the algorithm. It depends on the relations of them.
Okay, I think I understand now. Thank you.
Okay, so please stay here, Kaan, if you
Mhm.
want to work further and have questions. Okay.
Okay. May I ask a question? I'm sorry, may I ask a question?
Yes, Kaan.
Hello, Hocam. I have some issue happens to pairing this data sets. May I share my screen to show it?
Yes.
Yeah, in that part, the loading images part, I had some issue. I think this code.
We had just the same problem. It's due to the Colab, not the notebook actually. We just copied, yeah, like rewrite the whole code again. This like the cell. So I'm just copying
Okay.
this new image. You can delete the cell and insert a new cell, and I'm just pasting over the chat.
Okay.
We had the same issue. If you just copy that text and like paste it in new cell, it would work. At least it solved our problem. We're not so sure why does it works like that, but
I think is a just
yeah, exactly the same one, but it works like that. But it's due to the Colab servers. We had the same issue again.
yeah, let me try it. I think it works, but
Okay.
we will see. Yeah, I think it works.
Okay.
Thank you.
So
Thank you.
maybe I just post it into the Discord as well. Okay. So does anyone has any problems besides Kaan? I'm copying that hatch into our Discord channel as well.
I think the whole code is not completed. I don't have the data set to load location. I need the NPZ file, right?
Yeah,
This part of
the MPZ file will be automatically generated by the notebook.
this code will be okay. I can see,
Okay.
but
It would write it down. So the MPZ file is like that, but you have to open the training results file folder in your drive folders. You have to follow the same steps. For example, I'm just sharing my screen. As you can see right now, I'm also running down the code for training the machine. For example, we have a folder named as training results tree, in which the output would be saved. So you have to open in somewhere where you have the data set as a training results file folder. So change the file name according to that file path location. In both here, and somewhere upon here needs to be changed to. So This is the only thing that you have to change actually.
Right, thank you.
Okay.
Can I ask a question again?
Do you have a question?
Yes, I have a question. I'm sharing my screen right now.
Okay.
I checked this parent part, the conform, but the image sizes are I kind of didn't look well.
Did you change the file sizes in terms of like as like 1 hour ago, Mustafa had showed the file paths, the image sizes in the code.
Uh-huh.
Did you change that? You might be just missed one point in order to increase it or decrease it
I
in the
decreased
code.
the files. Yeah, resized spectrograms, resized and processed image. In that part, what is the? I have a problem with the is spectrum images or the architecture.
I think it's because of the codes, like the generated paths. I'm just checking it to the original codes size, pixel size. Can you scroll towards the upwards and load, split, and scale the maps dataset ready for training. 19th cell.
Yes, this one.
This one, it should be size. Can you zoom a little bit?
Zoom. Okay.
Okay.
Yep.
Sorry. I'm just
Okay.
checking.
Mhm.
Ultimates. The file sizes are hocam not this pad, the load, split, and scale. The commented version writes that the 19th cell in my case, but in your case it's different, I see.
Resizing images part is that part.
Yep.
Actually.
Below that actually.
Okay. This part, right?
Just a minute.
I think this part I have a problem.
Loading images part. Loading images. After resizing and pairing, loading images part.
Mhm.
Yes, it is the same. This is the same. Yes, perfect.
Yeah, we have a problem on the part. I'll change it.
This is the
Um,
part.
Mhm.
So your architecture samples are going in that way. The invalid syntax, is this the one that we have just copied the new code? The upper part, there's an error that just I saw.
I can delete it.
Yeah, okay, you can delete that cell, but it doesn't solve your problem.
Yeah, sure.
Actually. Yeah, okay.
But this is the new.
Yeah. I'm just checking the file sizes because there should be some mistake. That's why you have that error. Or your file sizes when you just resize it using another notebook. Did you just crop your and resize your images through this notebook or use that notebook as well?
That notebook I use in architecture
How-
images. I use this
What was the thumbnail definition in that part? The
image
thumbnail
resize
would
and
be
crop.
like 200 pixel to pixel. That might be the issue. If you
Mhm.
increase it and save that images, like I use that part 600 this time before I upload to the main workshop destination folder. Just try this one. Import your all processed images into that one, and take that all processed images into the other notebook. Do
Okay.
you get what I mean?
Yeah, sure. I create
Okay.
the second processed image
Okay.
file.
Just drag your images from that folder into the other notebook.
Mhm.
Maybe
Okay.
it would work right now. Because it might be too small, 200 than to 260.
Yeah, I think that's the problem. Thank you, teacher.
Okay. You don't have any class view. Okay. We will be here. Don't hesitate to ask any questions.
Okay.
Okay, so just a second. So I guess we came to the end of today's session. Anyone else other than Kaan who would like to share where they're at? Otherwise, we're gonna meet. Kaan, do you have any questions? Oh, I can't hear you now. I don't know why.
Is this work? No.
Is it from you? Huh.
Okay. I think it's okay for now, right? My voice is
Okay.
fine.
Okay, yeah. Then you can hear me, right?
Yeah, I can hear you, teacher.
So in tomorrow's session, we're going to be talking about the results and come to a conclusion. And if the participants can share what they have and their data sets and their experience about the notebook, then we're going to talk about that too. So let's say we'll meet tomorrow morning at 10. See you all.
See you, teacher. Actually, I have a results right now.
Oh, you do?
Yeah. The train part is kinda it took long to. It's approximately 1 hour. It's took long, but I have some model file, and the source and generated and expected images is now just I want to share my screen to show it.
Okay.
I'm kind of this step I approach. And yeah, this is the one of the Frank Gehry's masterpieces, and the source is the spectrum of the audio, and the generated part and expected part is kind of similar in that point.
Mhm.
No, this is the part you loaded the training set. The you are not training the model yet.
I'm not trying. I just I create the train. I have a training models.
Yeah.
Kind of
Can you show them?
I'm sorry. I can't hear you.
You did the training. The training is ended.
Yeah,
for you.
I did the training, and training is ended for me. I'm kind of 6 model files and the plot files on
Okay,
the part.
so now you are going to translate the images at the below. Yeah. Okay. You just run them.
Yeah, I run them. In that part, I don't use this this part, but I think I have a model file and I have a pictures. I can use this file. This notebook too.
Yeah, if you can provide new spectrogram that doesn't included in your data set, it will new architectural images, or it will try to generate some new things. Do you have any new spectrogram files?
Actually, I don't have, but I don't know how I create the new spectrum files. I need to find a new audio file to convert the spectrum file. Expect this all audio file I imported on that part.
Oh, okay.
I need a new spectrum, right?
You don't have to need. You can just run this part with the cell above 2. So can you just go up in the code in the code.
Uh-huh.
And yeah, if you can just run the libraries, and then if the file location is true,
It's
you can
not
just run the next cell too.
in that time. It's not true. I'm gonna try to new.
Okay.
And for example, but I need to pick the spectrum PNG, right? Not the architectural image PNG.
No, yeah. Spectrogram PNG.
Spectrogram, so resized one, I believe.
No, you don't have to use resize, but you can.
Okay.
It doesn't matter.
Then I want to pick some of them.
You can choose
Yeah.
one and just try it. Yeah.
Yeah, for example, this one.
Let's see.
Yes.
Okay. Here's your new generation.
Okay. Thank you. That's cool. It's like a some mock-up arts thing.
Yeah, it's kind of abstract at this point
Abstract. Yeah.
because of the low data set, but it
Mhm.
will become much better with the increasing data.
Yeah, sure.
But it's a good work. You just run a Pixel algorithm from scratch.
Thank you, teacher. One question about if I click again, this image is showing up again or new?
It will become it will be same or just a similar one, but
Similar one.
same because the pixel matches of the spectrogram images are the same. So if you just another new spectrogram, it will create some new things.
Yeah, for example, I tried this one, and of course it's changed. Yeah. Yeah, it's kind of building into sky.
Yeah, you can see the outline. Yeah.
Mhm.
But if you just increase your data, it will become much better.
Actually, I want to I want to increase the this image resolution with the I use this software, and there is a bunch of algorithm is patched on that software, and I use the super resolution on that part. I want to apply to the output of the these things. Yeah. Tam olarak nereye indirdim? Where I downloaded, I forgot about that. But okay. For example, this image, and I use the algorithm is the ESR GAN, the multiply 4 times and enchant with the AI generated. And of course, this is the generated.
Yeah, it will become much better in resolution.
Yeah. This is the old one, and this is the
Yeah, much better.
yeah, that's all. Actually, it's the all
What software is that?
This is the visions of chaos.
Okay.
Yeah, and there's a bunch of mods on that part, but the machine learning section, there was a super resolution algorithms I use that besides of the collab, and the text to image is of course is kind of working. There's a bunch of open algorithm. For example, the Discodiffusion and Dolly, and RU Russians Dolly, for example. there's a bunch of text to image algorithms are collected and packaged on this software. So yeah, I use this as a simple hot design, and yeah, this is the kind of software.
That's kind of cool. Yeah. I will try it.
Yeah, of course, I can share the download link and all of the install information. I can
Yes.
share with you, teacher.
Thank you.
Thank you.
Yeah, that would be great, Kaan. And tomorrow's session, we're gonna share our output.
Mhm.
And the visions of chaos that you use, that's a great example for this thing that we're doing here is actually trying to learn the algorithms and use the algorithms, trying to understand what does what, and trying to understand whether we can control it or not. And those ready-made software is great. It gives out a lot of very fascinating results. But then you don't have the main controls in your hands. So there's an explosion of this type of software and applications, which is leading to an enormous creation. Thank you for sharing.
It's no problem. Actually, yeah, I love to work with the collect file and the open source algorithm that I can change it. I can change all of them, but sometimes some algorithms didn't need to be changed. It's simple. This algorithm is just work spontaneously and just to fabricate the process again and again. So in that parts of algorithms, I use this kind of softwares, but the learning part and this machine learning things, I need to change of course, the parameters and see the results besides on that.
Okay. So let's meet tomorrow in our last session. Bye.
Bye bye. See you, teacher.